let's do this. This is the depth first traversal approach for the graph. So we're using the same, well, basically the same edges. You go from 0 to 1. Remember the last time when you do like breadth first search, you go to like, let's say you start from 2 and then you go to 0 and 3. Sorry, my mouse is freezing. Oh, okay. I don't know why the mouse is just like freezes suddenly because of I have other tasks in the background. Would that be why? Okay, but anyway, I just want to I just want to say that the difference between breadth first search is you go through like the width first. So you start from 2, you go to 0 or 3, and then you go to 1. So 1 is the last one. And the approach is you use a queue and you just pop it out and then append let's see, vertices to it, and the queue has a first in, first out order, versus if you do like depth first search, it's gonna go as a stack which goes first in and last out. So if you go from 2 and then you go to 0 and you keep going to 1 until you reach to the bottom of this loop. And then you go to 3. So let's implement this into code first. Yes, you should just say code, debugging code, not codes. You don't put program there. Anyhow, no biggies. Alright, let's just relax. Just, take your time. You've already done what you have to do. So let's construct this class first. We're gonna initialize a self object which uses self to represent this class graph, and you want to get the graph as a default dict. Oh my god, please watch your pronunciation. Dict. Okay. So from collections import default dict, and we have our second function, which is to add the edges of different vertices into the graph. You just any graph, append your vertex into it, and then we do a DFS where actually before you do the DFS, so there's a similar thing where you need to do is to do a recursive call where you would need to go visit all of those things to check if they're visited or no. So you go like well, you put things as visited dot add this one vertex, and I believe you can also just print out your v here, and we go through the loop for neighbors And this is better, like you just, instead of just putting I, just putting like one letter, it's better to make it clear for neighbors in self, the graph. And we're talking about V here, the ones you added there. If, then we check the visited. If neighbor is not in visited, remember last time we used this visited as a boolean, so you set the condition to be either true or false. So if it's false, then you need to revisit, no, sorry, just visit. And this one is to put it in the, actually it's a set, and then you just check if it's inside of that set or no. And if it's not visited, then we have to visit it by calling this object of the function v visited, something like this. And now that we have the recursive call, we just need to set our visited as a set. And what else? What else? Yeah, I guess that's almost about it, except you need to call that function to get the final result. V visited, similar to here, I guess. Just put V as visited, that's all it's been doing, and then return V. I guess this should be alright, and I've already put like all these edges as similar as the last time, just how the pointer, how the edges are connected. So let's call this file, this class, I believe the name was, I don't remember the name, graph, okay, graph, depth, first, traversal.py. Okay, cool. If syntax error, if neighbor is not in visited. I guess you don't need is. Not if neighbor not in visited. Yeah, let's see. Type object collection dot default dict has no action, no attribute append. Is it like, okay, yes, you need to put list in there. So it's a dictionary with lots of lists. Oh my god, something is wrong. One, no, what's the problem? Maximum recursion depth exceeded while getting the string of an object. Previous line repeated 900 more times. Okay, this happened before, just because things are like going recursively. So it's only visiting this one because you start from 1, so it didn't go anywhere except going recursively. Of course, of course, of course. Of course. Well, you need to fix this. Something is not correct here. Should I put this V in? No idea. Set is not subscribe if neighbors in visited. So What? I have no idea. Looks weird. Cannot assign a function to function call here. Assign a function call here. Oh my god, now I'm getting so confused. Again, well, it just so happened like when I'm just doing it by myself. Yeah, there's always gonna be like minor mistakes. So somewhere along the line is not correct. And let's bring your monkey brain back and try to figure out this thing. You have this set of visited, and this is also the set. Actually, can I print visited instead of printing the V? Well, if it had repeated 900 times, then I guess it's just gonna be a set of 1, 1, 1, 1, 1. So what are the differences here? Apparently something for neighbor. Okay, sorry. You want to put neighbor in here. Why are you putting V in there again? Because V is already inside, like, okay. I guess the whole algorithm, yes, I forgot actually to write down the time complexity, which is the big O of vertices plus your edges. So if you look down here, basically what this thing is doing is it add the vertices, which is the V, and the edges. For each vertices, you have all these neighbors, which are the edges. Neighbors, right? You use, okay, not exactly, but like you use all these edges to get, excuse me, to get to your neighbors. So you put neighbors as visited, because if you just keep putting, you're basically putting everything, or like the first one you encounter, you just put it as visit when it's already visited. So you didn't mark it, and now you're marking it. This is to mark as visited, and you in the iteration right. Okay, let's try again. Not exactly what I want. No, this is not correct. The correct answer is here. So let's see. It's getting weird because it's going sort of like 1, 2. Okay, that's actually correct. No, 1, 2, 0, 3, 1, 2, 0, 3, and 2013. I don't know how or why it got printed this way. I guess because the way you print things. So that's correct. We solved this one. We need to move on to a little bit more difficult one. You shouldn't get stuck in this kind of error, syntax error, or just typing error all the time. Last time it was like the range. You kept saying you need a range. You don't need a range in a graph. You need vertices. Okay. All right. I guess that's it. See ya. Love ya.